and welcome back to the new show where we talk about math. We go to our correspondent, Abdul Hakim. Abdul Hakim, can you hear me from the studio?
Yes, I can hear you, Eamon, from the studio.
Well, that's good. Tonight we'll be discussing the area and polygons from chapter 7 of the textbook. So you have a special report on this?
I have a special report. But first, can you please explain to the audience what perimeter is?
Now, this is my special report on perimeter. Hello and welcome to this introduction on chapter 7, which is about measurement. The main topics we'll be discussing today are perimeter and area of many different polygons and circles. I'll be discussing the concepts while Abdul Hakim will use sample problems and demonstrate how these concepts apply to the real world. Let's begin. First of all, the perimeter of something is the total distance around its boundary. For example, if you have a polygon with n number of sides, then you add all the sides up to get the perimeter. For all polygons, a polygon being plane shaped with straight sides, all you have to do is add all these sides together. When you find the perimeter's result, you will use metric units of millimeters, centimeters, kilometers, etc. For circles, which aren't polygons, because the lack of verticals and half are pi d. As displayed on the screen on my right, now if you want to use this formula to find the length of an arc, which is the part of the circle's outer layer, then you have to use the formula of theta over 360 times 2 pi r. While with this, you can find the length of the shaded area. Remember, the length of an arc will always be lower than the circumference of the circle.
Thank you, Eamon, for that discussion on perimeter. Now, the second main topic that we're going to be discussing is area. An area is the region that a surface has within its borders. You can think of an area in terms of the polygon as a swimming pool, and the shape of the polygon determines how much water is in it, as in the area. We all know that pools come in different shapes and sizes, and that is true for polygons. Unlike perimeter, the shape of a polygon plays a big role in the formula. Area is measured in square kilometers, square centimeters, square meters, and square kilometers, etc., in all metric units. For each of the following polygons, there is a different formula for finding the area, as displayed on my left. And this will be discussed into further detail inside this website and throughout the PDF. For this video, we will focus on the area of the circle, which is pi r squared. To find a shaded area of a circle, called a sector, you would need to find the angle of the sector. Then you need to apply the formula of theta over 360 times pi r squared. For example, this can help you in real life as well. If you're going to have dinner with your friends and you decide to split a pie or a pizza, you can use the formula to find exactly how much of the pizza or the pie you need to split, as discussed here on the right. And thank you for watching. And now we return to Eamon in the studio to use what we learned in a practical way using example and higher level questions.